In this type of story problem, we're going to be dealing with acceleration, the net force of an object, and mass. So acceleration, force, the net force, and mass. Find the force. So we're right off the bat, we're looking for force. The variable for force is F net, or just F. Okay? So we want to find the total force used to push a 100 kilogram box. Now I did say mass was 100 kilograms, but you must know that the unit kilogram represents a mass. The variable for mass is 100 kilograms. So we're looking for force. We have a mass of a box that accelerates 2 meters per second squared. The variable for acceleration is A. Now everything in this class we deal without friction, so we assume there's no friction. That would change the problem up. So we have force, we're looking for force net, we have mass, we have acceleration. Now the equation that relates force, net, mass, and acceleration is the acceleration is equal to the force on the object divided by its mass. Because we're looking for force net, we need a force that equals something. So we need to go to, again, our triangle trick. We look at our equation, we have force over mass. So force must be up top. And mass, it doesn't matter what spot, just has to be on bottom. Leaving with our other variable, acceleration. We're looking for force, so we cover force, and force equals mass times acceleration. Now that we have in step 1 what we're looking for in step 2, we can go to step 3, our problem solving. Step 3, force equals our mass, which is 100 kilograms, times our acceleration, which is 2 meters per second squared, and 100 times 2 is 200 newtons. Newtons is the units for force. So to recap the story problem, we're looking for force, net, the total force on an object, times its mass and acceleration. The equation relates these three variables, A equals F over M, or simply our force equals mass times acceleration. Once we use the triangle trick or algebra, and then we just plug and chug.